Welcome to SPSS, PSY 3840, and I'm Professor Coolidge, and let's go to our assignments. We're up to Unit 2, Frequencies and Graphs. Let's click off this edit mode, and we'll go Frequency and Graphs lecture here. And we are going to learn how to look at our frequency distributions and construct one. And we're going to need this schizoid Asperger's control SPSS data set. And we'll learn all of these things, bar charts, histograms, and talk about skewness and kurtosis. So let's get started. We'll go into our data set here and find our data set. Now, remember, if we have this opening existing data source, we can look in here and see if we can find our data set. And it looks like we do have it right there. So I'm going to click on that, open it up. And we have our data set. So let's first create a frequency distribution for age right here. So we'll go to Analyze, and we'll go to Descriptives, and we'll go to Frequencies, straight across. It'll default on the first variable, and that's the one we're going to deal with. So we'll click over age, and we won't bother with any of these other things. Let's just go here to OK and see what we get for saying OK for frequencies. It went into the statistics viewer, which is really our output.spo file, and here's what we've got. 71 valid cases, no missing for age on the age variable. And it says we've got 5 3-year-olds, 9 4-year-olds, 6 5-year-olds, 4 16-year-olds. Nobody's missing an age. We managed to get age off everyone. What the percent here is of this total 71, you have 5 3-year-olds. What percentage of the whole set are 3-year-olds? And it tells us it's 7%. We go over here to cumulative percent. Notice it says we've got 9 4-year-olds, which is 12.7% of the sample. And on the cumulative percent, it's going to say, okay, 19.7 have an age of 4 and 3. It'll go lower in that on that variable. And so that's about 20% of our sample. You can see when we get to 5-year-olds, cumulative percentage, it's 8.5% of the total data set are 5-year-olds, but 28% are 5, 4, or 3-year-old. Now, as we keep going up here, we can see that our median, where half of the data set is above that age and half of the people in this sample are above that age, the median at 50% occurs somewhere between 7 and 8 years old. And you can see when we get up here, and we have at 16 years old, of course, it would have cumulatively 100% of all the data there. We're not going to save this output, so I'm going to X on the .spo file and say no. And let's go in, Analyze, Descriptives, Frequencies, and now let's look at, we'll skip statistics for a second and go to Charts for age. And we see that the default is no charts, so let's say a bar chart. And we'll take all the defaults and we'll say continue, and we'll hit OK. We're in our output. And now we see that same frequency distribution, which was kind of the default, and then right below that is our bar chart. And know that the subtle difference between a bar chart and a histogram is that the bar chart has spaces between these bars. So let's look at it again. We see 3-year-olds, current age. What's the frequency? Well, it doesn't list 5, but we can clearly see that's 5 years old. 5 frequency. So 3 years old, there are 5 of them. 4, remember there were 9, right, between 8 and 10, 9. And we can see the kind of the shape. This is a graphic presentation of the frequency distribution. It certainly doesn't look normal. Normal curve would look like this, and we can actually order that in a little bit. But now we've got our bar chart. We can see that in some respects it looks a little flat for a curve. It doesn't have a peakedness. If there's any peakedness, it's up here, maybe a little bimodal here. Okay, let's again not save this. because every time we order something, it will come on the end of this output, and then we'll have a lot of redundant data. And let's go into Analyze. Descriptives, frequencies, back into Charts. Notice it keeps age. This time we're going to hit Histogram, which is like a bar chart, but no spaces between the bars. And it'll say, show the normal curve on the histogram. And let's see what a normal curve looks like against that. Continue. Okay. Our same tabled frequency distribution. That's the name of this thing. Here's our histogram. And you can see what's happening here is these bars show that it's a little bit flatter, it looks like, than the typical normal distribution. And it seems to be a bit skewed too. So it's like the bulk of the data is here, just as we saw before, and some more cases further out here, although not badly skewed. Is it mound shaped? It's sort of debatable, but I'd say yeah, it sort of looks like a mountain. Okay, again, we will not save this. And we will say no. And now we're going to do the same things. Descriptives, frequencies, take the default. Now we're going up here to statistics. And what we'll order here, although we could order the mean and the median, is these two and the shape of the distribution. We want to see the shape of this distribution, and we're going to go skewness and kurtosis. And we'll hit continue. Now what this is going to do is give us a measure of how skewed the data is and a measure of how peaked or flat our data is. So here's on skewness, you see, it says 3.64. If there was no skew whatsoever, perfectly normal, this would be 0. How can we judge how skewed it is? By this standard error. We can kind of consider it like a standard deviation. So you can see that it's like something more than a standard deviation skewed. It's positive, so there's a positive skew, which we saw. Kurtosis, which I suspected were a little flat. If it was perfect mesokurtic, it would be perfect normal distribution. It would be 0. It's negative, so that means it's platykurtic, flat, which we saw. How flat is it? Well, here's about a standard deviation. So we can see it's probably more than 2 standard deviations flat. And notice that we could tell that when we just looked at this superimposed normal distribution. But these two interesting statistics right here give us a measure of the skewness and kurtosis for that variable. Okay, we're going to X out of here also again so it doesn't keep saving it. And now let's go analyze. And we'll go into descriptives and frequencies. And this time we want to get rid of age, move it back over. So notice when I highlight it over here, it's going to let me kick it back over. It goes back into its position. And what we're going to do is look at the total autistic symptoms variable. So that's right here. And now this was a sum of 45 items. So that's the total autistic symptoms, and the variable name was SASTOTE. And we're going to do the same thing for SASTOTE and create a frequency distribution. And we'll go into these statistics. And again, we're going to get skewness and kurtosis. So we'll say continue. We'll look into charts. And notice it's kept the default each time. So we'll go there. And we'll say OK. And now we see, again, this is a positive skew. And let's look at the statistics first. And it's more than 2 standard deviations, so it's very positive skew. It's also platykurtic, not as platykurtic as we saw before, but it's platykurtic to a great extent, almost 2 standard deviations platykurtic. And here's our frequency distribution. This is very interesting. It's a sum of 45 items. And what's glaring right here is this value of 30. If that was coded correctly, that meant a parent did not answer 15 questions for some reason. And when we went back in and looked at this variable, we saw indeed the parent just refused to answer, and everything else was a 1. So the parent's not cooperating very much at all. I wouldn't say this is an outlier. I'd say it's a clinker. And so we may want to eliminate that from our data set from any further analysis, and that's why that frequency distribution, sorry about was kind of useful by just looking at, say, is this a valid score? We could have done the same thing over here and made sure that you couldn't have anything more than, if there's 45 items times 4, like a score of 180. So if we saw a score of 249, then we'd know, well, something's wrong there. The data must have been coded badly. Again, here we see that positive skew because of more of the bulk of the distributions over here leading positive skew. It's still kind of flat and representing the platykurtic. Okay, let's go over here and we'll X out of this and we'll say no. Now we're going to go back in this data. I want to find that person that had a 30. And so as I'm looking through SASTOTE, I'm going down here and I'm eyeballing these as I bring it down. And there they are right here, a 30. Now something else that makes me think this parent wasn't cooperating is there's 7 items on the schizoid scale. They're answered on a 1 to 4 scale also. So a parent could deny everything and have a 7, and we see a couple of them. But this parent that skipped 15 items here, 7 1s here, we're just getting no cooperation whatsoever. So if I highlight this case, and I've checked out the original data and decided the parent's not cooperating, it's a clinker, not an outlier, I could go clear, and the case is gone. It moved up case 48 now to 47. And if we look down here, we see our case numbers. Now we only have 70. So we'll go File, and we save it, and we'll save it in that location. SPSS likes to tell us that indeed it saved the out file now to those 70. So we'll hit OK and not save that output. And now let's practice one more time with the schizoid personality disorder. So I like moving this thing back up. I feel like I'm starting at the beginning. We don't have to do it. Descriptives, frequencies, kick back. Let's go to our 7-item schizoid scale. We'll kick that over. This is a sum across the 7 items. Watch this. When we click here, statistics, it kept what we had before. So our default becomes whatever we ordered. Our default becomes whatever we ordered. We hit continue. We hit OK. We'll check out the frequency distribution here first and say, okay, 5 people denied any loner tendencies for their children whatsoever, but we don't have any 6s or 3s, so that means at least they answered all the questions on this test. If there's 7 items, times 4 is 28, so we don't have anything greater than 28, but this parent is obviously saying they're giving their child a lot of 3s and 4s that ended up on that scale as the sum. If we go down, oh, let's go back up here, and we can see, again, we got a positive skew. We're getting closer on kurtosis here. We're getting, this is the smallest negative number we've seen, and it's only half a standard deviation approximately platykurtic. So we're approaching the normal distribution, at least in terms of kurtosis. We are not. We've still got a very positive skew here, which you might expect with some types of psychopathology, is that you're going to get most of the children, the parents of most of the children are going to say, no, they just don't have it, and a few that have it with a relatively low frequency. And that's what's going to produce very often a positively skewed distribution for any psychopathology that we are investigating. And that is our lesson for today. If we wanted to save this now, hit this X, and we actually wanted to save this, and we went save the output, we could go over here to our desktop, and we could name this output. And notice it says .spv here. And we could name this output and say this is the schizoid frequency distribution. It'll save it with the .spv, and we'll say save. And now it's saved. And now if we went here and we looked at recently used data, we see our recently used data, recently used files, notice when these are the data files, those .sav files, and here the .spv file, which was that output file. And we could call it up, and we'd have it back again. So now if we say, since it's saved and X out, it's already defaults to that save. And that's our lesson for today.